Hello friends. Friends, today we will discuss field intensity on axial line of electric dipole, or in other words electric field intensity on axial line of electric dipole. Now first of all, let us discuss what is the meaning of electric dipole. Now electric dipole consists of a pair of equal and opposite point charges, pair of equal and opposite point charges separated by a small distance this is known as electric dipole. Now another term, that is dipole moment, we will discuss here. Now P, that is dipole moment, is a measure of the strength of electric dipole, that how strengthened is the electric dipole. So P is equals to Q multiplied by 2A. Now it is a product of magnitude of either charge and distance between them. Now what we have discussed, minus Q plus Q, equal charges separated by a certain distance 2A. Okay, this is dipole. What is dipole moment? Product of magnitude of any charge, that is maybe this charge or maybe this charge, because magnitude will remain same, multiply with the distance between these two charges. It is known as dipole moment. So now we will calculate electric field intensity on axial line of electric dipole. Now we will calculate the electric field intensity E at a point P, on the axial line of dipole. Now what is the meaning of axial line of dipole? That is a line passing through the positive and negative charges of dipole. That is a line passing through the positive and negative charges of dipole. Now here it is the line passing through the positive and negative charges of the dipole. It is known as the axial line. So we will calculate the electric field intensity E at a point P, on the axial line of dipole. Now point P can be here, point P can be here, it can be here, okay, but the axis is the axial line. Okay, so we will calculate this. Now distance between the center of the dipole to the point P, we have taken R. Now why we take the separation 2A between the two charges? Because calculation will become easier, because when we will make it half, then it will become A, and if we will take the distance between these two charges A, then the distance while calculation half distance will become A by 2. The answer, there will be no difference in the answer. So the distance between the center of the charge and the point P, where we have to calculate the electric field intensity, is R. Okay, now at a distance OP is equals to R from the center O of the dipole. Now if E1 is the electric intensity at P, due to charge minus Q at A, due to this charge there will be influence here, and E1 will be the electric field intensity due to this charge, and its direction will be along PA, along this direction, because in one of the video lectures I have told that due to negative charges, the direction of the electric lines of forces are inwards. So here the direction of the charge will be along PA. So electric field intensity, by definition or by equation, E1 equals to 1 by 4 pi epsilon naught Q upon the distance square. Now here the distance square is AP square. Okay, because the charge minus Q is placed here and the distance is from A to P. And what is AP? AP is basically R plus A, because the gap between minus Q and plus Q is 2A and it will be A here. So total AP will be R plus A. So E1 equals to 1 by 4 pi epsilon naught Q upon R plus A whole square along PA. This will become equation number 1. Now let E2 is the electric field intensity at P. At P due to charge plus Q at B. Due to charge plus Q at B. Now its direction will be along BP, away from charge placed at B, that is plus Q, because due to positive charges, I have discussed in one of the video lectures that the electric field intensity, that the direction of the electric lines of forces are outwards. So E2 is equals to 1 by 4 pi epsilon naught Q upon BP square. Now what should be BP? Now OP. What is OP? OP is R. Okay, so BP here is R minus A whole square. R minus A whole square along BP. Okay, R minus A whole square along BP. Now as E2 is greater than E1, therefore resultant electric field E will be along BP. That will be E is equals to E2 minus E1. E is equals to E2 minus E1. So if we put equations 2 and equation 1 in this equation, so using equations 1 and 2, we have put the values of E2 and E1, then Q upon 4 pi epsilon naught we have taken common out, then we will take the LCM, R square minus A square whole square, R plus A whole square, R minus A whole square. If you will solve it, it will become 4AR upon R square minus A square whole square, because A plus B whole square, put this formula here, A minus B whole square, put this formula, you will get this result. Okay, you will get 2RA plus 2RA, it will become 4RA or 4AR. So resultant electric field become Q upon 4 pi epsilon naught 4AR upon R square minus A square whole square, or electric field intensity is equals to Q multiplied by 2A multiplied by 2R 4 pi epsilon naught R square minus A square whole square. Now what is Q multiplied by 2A? This is dipole moment. So we can put P instead of Q multiplied by 2A. So electric field intensity for axial line of dipole will become P upon 4 pi epsilon naught 2R upon R square minus A square whole square. This is the result of electric field intensity on the axial line of dipole. Now there is a special case. Now if dipole is very short, that is 2A is very lesser than R. Now what is R? R is the distance from the center O to P, and 2A is this one. Now if the dipole is very short, then 2A is very lesser than R. Then P power 4 pi epsilon naught 2R upon R square whole square, because A square is negligible. So we have neglected A square from here. Now what will left? R square by R square upon whole square. So R square will become R4, and this cancel out. Electric field intensity is equals to 2P divided by 4 pi epsilon naught R cube. That is electric field intensity due to dipole on its axial line is inversely proportional to R cube. This is very important question, maybe for the derivation point of view and also for the MCQ type, that what is the relation between the electric field intensity and the R. Okay, distance from the center to the point where we are calculating the electric field intensity. So This is all about the calculation of the electric field intensity on the axial line of the dipole. I hope you have understood the same. If you have any doubt, please share in the comment section. Thank you. Thanks a lot.